In this first section today, we're going to look at energy resources as a whole, and then we'll focus in specifically on petroleum and natural gas. So the case study that's in your packet is about conventional oil. So there's questions about how much oil do we actually have. We can't necessarily say for sure. It's hard to determine all of we have known reserves and we have like potential reserves where we think there might be natural gas based on rock strata, the types of rocks that are in areas where we would normally find gas deposits, but it's not saying that that petroleum would necessarily be there. So these three that are listed on your screen are known reserves. So obviously we know that one of the largest suppliers of gasoline and petroleum products are in the Middle East, and Saudi Arabia is kind of at the top there. So these numbers were from a little while ago. So they're from about like 2007, 2008. So if Saudi Arabia were solely supplying the world's oil supply during that time, since these numbers were written, well, then they would be just about out of gas. Now, obviously, they haven't been supplying it all, but the point is that if one country had to support everybody, we wouldn't have very much out of that country. These two, the North Slope and our Arctic National Wildlife Refuge, have been in the news quite a bit lately with starting up new pipelines and things like that. It's always been a little bit of a contested area because of how sensitive environmentally the National Wildlife Refuge is. Whenever you're in the tundra areas, your ground and the vegetation is much more sensitive than in areas where you have the taiga, where you have lots of trees and things like that. Just the tundra takes a lot longer to recover from things like that. And if we're supplying everyone in the world, even if we're just supplying ourselves, it's a stopgap. It would be something that could get us through, but it's not a long-term solution by any chance, by any stretch of the imagination to our energy needs. So we're not entirely sure. There was a gentleman who, his last name is Hubbard, and he predicted that we would get to a time when we would reach our peak oil production, and then after that time, the reserves would be depleted and they would start to slide down. Now, like I said, it's really hard to tell when we get to that peak because we don't know all the areas where petroleum products are available to us. We do know that when we have to drill, for example, like this picture here, we have to drill in the ocean. That's a little bit more complicated than it is when we can drill on land. So we need to look for ways to extend our gas supplies and our petroleum supplies by finding either alternate resources or through energy conservation so that we don't need to use as much petroleum products in order to accomplish the same task. So our primary energy source is the sun. So when you think about it, so even petroleum products, initially that energy came from the sun. The energy comes down from the sun, plants photosynthesize, and in the case of most of our non-renewable resources, as far as energy resources are concerned, come from compacted decomposing plants and animals over large periods of time. They get compressed, excuse me, they get buried under the soil, it keeps continuing to pile up on top of them, they get compressed, and then they turn into our oil, natural gas, and coal. So it's all coming from the sun, for the most part. So eventually, that's where its direct source is. Now, our wind power and everything like that, when we talk about how solar energy indirectly supports wind power, wind is the result of uneven heating of the planet. So the crust heats up, the air rises above where the crust heats up, and then the air moves from an area of high pressure to an area of low pressure, and it gets kind of pushed, and that's wind. And it all happens because the earth is heated by the sun. So that's why solar energy supports wind power. Hydropower, we rely on the movement of water, and water moves because of the gravitational pull of the sun and the moon. So once again in there, and then biomass, once again, bio meaning life, so this is material that we can burn that was once living. So we're talking about things like trees, okay, when we're talking about biomass. Some other things that we could be talking about would be like cow dung, or it could be peat, which is vegetation that grows in like kind of swampy areas. It's thicker areas. They had lots of peat bogs in areas like Scotland, where they would cut out the peat and then they'd let it dry and they'd like cut bricks of it and they would burn that. When we look at our commercial energy use, right now we are more dependent upon our non-renewable resources than we are on our renewables. If you look around, you'll see in your neighborhoods and in areas that we are becoming a little bit more dependent on our renewables. But for right now, our primary source of electricity in the Phoenix area is Palo Verde Nuclear Power Plant. So when we're looking at our different types of energy resources, we look at where they come from in here, and then how do we actually extract them. So one of the activities that you're going to be doing in this unit is you're going to look at what it means to actually extract gas from shale and from rock. And this is something that's been in the news a lot over the past few years. We talk about fracking. Oil can form in areas like this where it's kind of like in a puddle underground or a lake underground. But oil can also form in shale. And so at that time, when it's formed in shale, we have to find a way to jar it loose, basically, from the shale itself. And so when they frack, and that's not really in this picture, but what they would do is they'll drill down and then they'll drill sideways and then they force water into the rock, which breaks it apart and lets loose the gas, so then they can pull it out from those areas. So this is a more traditional well. You'll see that there's more than one pipe that's going down into it, more than one drill shaft. Some of it's going down into the actual reserve of oil. Some of it they're tapping the natural gas that exists above it in those areas. These beds over here are coal. So coal forms from ancient swampy areas. Those swamp areas, sediment builds in and fills them in and compacts them down, and over time they become coal. And that's why you see them happening in these layers like this. And so when the miners go in to mine these areas, there's a couple of different ways they can do that. In this particular picture, they're showing a mine shaft where they would go down an elevator, if you will, down into the coal seam, and then they pull it out. Or over here on the side where they're doing strip mining, where they're actually taking off the layers of earth over the top of the coal, and then they pull it out. So there's goods and bads to both of them, and we'll talk about those a little bit later on. Here's another look at our strip mining for coal. Over here we're looking at geothermal energy. So geothermal is considered non-renewable because so what happens in geothermal energy is these pockets of water that are trapped within the crust, they're close to an area where the magma is closer to the surface. So Iceland is a really good example of this. They have a lot of geothermal energy there, also in New Zealand. But when these pockets of water are exhausted, when they're gone, then the geothermal energy is gone as well. When we look at our different types of energy resources, and in your notes packet you might need to pause this one for just a minute so that you can fill in your pie charts there. But what we really want to look at is the comparison of us to the rest of the world. So how good are we doing with our renewable resources versus the rest of the world? And while the numbers may have shifted a little bit over time, the proportion is still pretty accurate. The rest of the world tends to use a little bit more renewable energy than we do in the United States. We still tend to depend a little bit more on our natural gas and our coal and our oil in here, and we also depend a bit more on nuclear power in some areas of the world. After Fukushima, when in Japan had its accident after the earthquake and tsunami caused the interruption of the electricity to the pumps, and so there was the nuclear accident that happened there. There were some countries like France who was very dependent upon nuclear power that kind of took a step back a little bit from developing new power plants until they could determine ways to safeguard against natural disasters like that. When petroleum, so we're going to shift a little bit from the how do we get it to what do we do with it once we have it. So petroleum, when it comes out of the ground, is really thick. It's not like the gasoline that you put in your car. It has to be heated up in order for it to become that. And so they do that through what's called distillation. They heat it up and they heat it to different, and at different temperatures is where you're going to get different products. And so I don't know if you realized how many different products we get out of petroleum, and there's actually more than what's on here that are petroleum products. So the coolest temperature, so the least amount of energy to create, basically, would be what we use for asphalt, the tar that's on the asphalt and things like that. But if you look up here, you'll see that gasoline, actually, to get the gasoline that we put in our car, we actually have to heat up the oil quite a bit in order to get that product out of there. See that as you go down here, this is where you have cooler temperatures. It doesn't need to heat up quite as much. Some things that aren't on here, petroleum products are what we make plastics out of. If you have nylon clothing or rayon clothing, those are made out of petroleum products as well. So there's other things that aren't on here, but just to give you an idea, you're going to be doing a little activity about the distillation of fuel in this section as well. So oil itself, or petroleum products, from the Middle East are predominantly, controlled by OPEC. So they have most of the world's oil reserves in their countries, and so they pretty much set prices. And when in the 1970s, we weren't getting along quite so well with the Middle East, countries in the Middle East, and so they reduced our production significantly. And they reduced their production, and they reduced what they imported or exported to us, and we imported into the United States. And as a result, we had some significant issues with being able for our economy to still function. This is when we had gas shortages and people were waiting in line. There was fights and rationing. It was not a very good time. There was a time in Arizona about 5 or 6 years ago when the distribution pipeline from Tucson up to Phoenix was broken and disrupted fuel supplies coming up to the Phoenix area. And we had just a tiny little taste of what that was like for the fuel lines. I remember sitting in line, and the lines were going like around the corner, around the block. Gas stations were running out of gas, and the gas prices went up about $1 a gallon pretty much overnight. So it happens periodically. Usually the interruption to the supply is fixed rather quickly, but unfortunately prices don't generally go down quite as quickly as a result. In this graphic, what we're looking at are the average prices over time, but they're adjusted for inflation, so that we're when we adjust for inflation, that means that we're comparing apples to apples, so we're not comparing $2016 to 1946 dollars, because obviously that's not a fair comparison. So this is where all the dollars are on an even playing field, and that's the red line that's on here. So when we look at in 1946, in comparative dollars, in 2006 dollars, it was about $20 for a barrel of oil. In 2008, during the height of our recession, oil prices went up to about $140 per barrel, which is significant, and that's when we were seeing gas prices that were approaching $4 a gallon here in the Phoenix area. In other areas of the country, they actually topped $4 a gallon. But you can also see that the market corrected itself rather quickly as the recession started to ease a little bit. And so the oil prices started to drop. We also increased production from the United States side of things. So we weren't just relying on oil from other countries. We started to increase our supply to bring down that cost. So there's some trade-offs using conventional oil. Obviously, it's something that we have grown accustomed to. It's easy to use. We have all the infrastructure in place. We get a lot of energy out of burning oil, whether that's burning it as gasoline or as heating fuel or jet fuel, however we use it. It's easy to transport. It's not very combustible. I know the movies show it like exploding. It doesn't really do that. So it's very safe to use. It doesn't take a lot of land area to drill for it. There's some other consequences, environmental consequences in the area where drilling occurs, and we'll talk about that a little bit later on. So, but the downside is the one that we all know, is that burning oil releases carbon dioxide and sulfur dioxide into the atmosphere, which, even setting aside the idea of climate change, is also contributing to acid deposition in our oceans, which increases when we increase the level of acidity in the oceans. We make it more difficult for organisms to survive because they have a range of tolerance for pH, or the level of acidity. And as more carbon and sulfur dioxide are deposited into the ocean, it lowers the pH or makes it more acidic in the ocean. And so we can have die-off of some of our ocean organisms. And a primary concern is plankton in the ocean. If the acidity arises too much, if the pH drops too much, then we can have the plankton die off, and they produce a lot of oxygen. They convert a lot of carbon dioxide into oxygen for the world, which is a concern. All right. The next thing we're going to look at is the hydraulic fracturing, or fracking. So this is a picture of what I was talking about. You are going to do an activity that deals with this. So this is showing, here's the mine, here's the drill shaft that's going down, and they're forcing water into it, and you can see on the sides here, that's where the cracking is occurring. And you'll get to see this, and you'll get to play around a little bit with it in an activity. But it breaks everything up, and then it releases the gas and the oil, and then they can actually reverse the pumps, and they can pull it all out. Just a few facts about our oil consumption. We consume a lot of oil. Things that you wouldn't necessarily think about being oil that lead to our consumption. So natural gas occurs above the top of the layer of oil, usually is where we get it from. So we pipe it out separately. There are some other ways that people are starting to trap methane, and we'll talk about that a little bit later on, but it's kind of cool. Actually, there's one, Mythbusters, that's out there, where they actually go to this farm where a farmer is running all of his power off of the methane that comes from the cow waste. He built a tent over a pond where he has all the cow waste goes down into this pond. It's a sedimentation pond, and then he has this big, it looks like a parachute almost over the top of it, but it's thick, and it captures all the gas in there, and then they pipe the methane out, and they burn it, and that's how they generate their electricity, which is kind of a cool way to use some of what would be a waste byproduct and making it into something useful. But these ones where we're talking about are the non-renewable resources. So they're going to tap it, they're going to pump it out, and then they're going to move it around in those big white trucks that you see. They're like the kind of bullet-shaped trucks. It's also still very safe and easy to move around. You'll see that Iran, once again in the Middle East, where they have a lot of the gas deposits, the petroleum deposits, the gas is right there above them. You'll see that we have a bit more time if we were to switch to natural gas. This is if we were to, when we say last 62 to 125 years, this is if we're using it at the current rate, not if we increase consumption. There, it's a bit cleaner burning than other petroleum products are. But some of that, remember, we have to look at the distillation and the burning of it, and there's still some pollutants, that are released at that time. But definitely cleaner than burning gasoline. So when we look at the trade-offs and the advantages and disadvantages, we get a lot of energy out of a very substantial supply of natural gas for a relatively low cost. So, and it's less polluting than other things. So it has some very definite advantages. That's why they're starting to do the compressed natural gas cars and things like that to lower emissions in areas. Once again, you have the same thing as has that lower land use. It can be piped, it can be trucked, so it's versatile in the way that it moves. Um, but once again, it's still a non-renewable resource. Eventually, it will run out, um, and it still does produce emissions when burnt. That's the end of this section. In the next section, we'll be looking at different types of non-renewable resources.